back to MycoSpace Trip. It's a glorious new day and we're ready to get right back at it. So the prints we ran yesterday, they went good and bad. These are both the internal frame structure for the living Merkaba piece. One side looks good, the other side looks botched. But thankfully, we have another printer here in the room and we're gonna get right back at it. And the second mold shell for 𝓏𝙏𝙏𝓀 came out pretty damn good too. Here we are in the bamboo slicer, highlighting all the parts the living Merkaba needs supports generated in. And right here we're also getting the internal frame for 𝓏𝙏𝙏𝙏 sliced and ready to print ASAP.
The next day.
Alright, so we got the internal frame structure for 𝓏𝙏𝙏𝙏, both sides made. This side had a little bit of a spaghetti thing going to it, but I don't think that's going to impact the end product. And the other side of the internal frame for living Merkaba, looks like it came out perfectly. It's going to take forever to get these supports off though. So right now we're going to focus on making the internal structure for our fifth piece, the internal frame structure, and then the exterior mold shell, just like with every piece. Let's get it. And here we are, getting the base of 𝓏𝙏𝙏𝙏, the flower pot for it, sliced and ready to print. Then comes the next fun part, manually building a frame structure around the original design. This is the process for creating the internal frame structure, especially for a form like this, along with the external mold shell, which is 5 millimeters outward from the original model. And as you can see here, it's the process used in cutting the internal frame to ensure it fits perfectly inside the mold shell. Right here, we're starting to build the fresh air exchange port on one side of the mold shell, drawing our magic sigil where it most definitely needs to be, creating the holes straight through the mold shell, right into the fresh air exchange port, making sure it lines up perfectly. Because later we're gonna have to cut that shape from the internal frame to ensure there's enough space for both the internal fresh air exchange port and the frame. Now we're placing another magic sigil where the next fresh air exchange port will be installed in the model. Everything's looking good, so now we begin creating holes on one side of the mold shell and pegs extending outward on the other side of the mold shell, just as intended with every piece.
The next day.
New day, more progress to be made. Let's get right back to it. Every mold shell is designed to fit perfectly with each other, and that's accomplished by sketching 2 circles along the entire rim of the center split line between both mold shells. One circle slightly bigger than the inner circle to be the hole, and then the smaller circle to be the peg extending outward, smaller so that I can fit inside the hole. And here we are, finally getting the living crystal mold shell sliced and ready to print. Then getting the pot base for living crystal sliced and ready to print. This pot is so big it takes up the entire print bed. Then we continue our progress working on the internal frame structure for living crystal, initially testing out different volumetric configurations. It seems the cross volumetric structure is the most optimal way to create these internal frames for the intended purpose of packing with mushroom substrate later on. Then continuing the process of manually building a frame structure for every crystal body in this crystal cluster form. The big reason behind creating an internal frame structure like this is to preserve the intended design after the form has been fully colonized. Since we're working with such an exotic medium, you can't expect it to conform to such a sharp geometric form, and that's what the frame is intended to do. It's supposed to preserve the final design at the same time ensuring that the mushroom substrate held within conforms to that shape.
Much later.
And we're back at the MycoSpace Station dojo. Here we begin the exciting process of creating oak wood substrate mixed with some wheat bran. And you can see I'm carefully measuring out every part. This particular oak wood wheat bran substrate recipe works with any gourmet mushroom one would want to cultivate. It comes mainly as oak wood pellets. The moment is almost upon us. We're about to pressure cook the substrate we need to start packing those sculptural molds. We're going to be doing that today with our very lovely all-American pressure cooker. Beast of a unit. The moment is almost upon us, where we finally get to run our proof of concept for this living mushroom sculpture. Now is the time to sterilize the substrate. And before we put our substrate bags inside the pressure cooker, we line the interior walls with some wet rags. It's just to prevent them from melting during the pressure cooking process. MycoSpace Trip. My fellow humans, my plants, my trees, my chain smokers out there. We are at the precipice of greatness here. Right here, you see this? Is the first design that ever came out for this concept. This version right here is the micro fairy ring portal. Micro because it's only 8 inches tall versus the full size that's 20 inches tall. The micro fairy ring portal is ready to be packed with substrate and colonized grain at last, at long last. But we still have 3 other designs on hand right now, with all the components fully 3D printed to run the same tests with. We just need to remove all the 3D printed supports from those components and we can start packing them as well. Isn't it glorious? Just the mold and the structure inside alone. The mold with the frame inside alone looks amazing. I can't wait to see what this looks like with mushrooms growing in this form. The world's first living man-made fairy ring portal. Let's get right into removing some of those 3D printed supports from the remaining components. We can start packing these molds. Finally, let's get it.
Look at that glorious living Merkaba mold. And these right here are the fresh air exchange ports that have been designed into the model. That was pretty clever, but we'll see if it works. In the earlier iterations of this concept, the fresh air exchange is done through holes. That's it. There isn't a buffer zone built into the model. And there could be some complications with there not being an air exchange buffer zone between the substrate and the fresh air outside, because the substrate contains some moisture and may prevent fresh oxygen from adequately entering the mold whilst allowing the CO2 to escape. The latest iteration of the living Merkaba internal support structure, covered in 3D printed supports. We gotta remove them, protect the portals, and not die. Let's hope I don't get any plastic scraps in my coffee, huh? Got all the supports off, but it's covered in PLA hairs. I think I know just the trick on how to remove them. Quick hit with the heat gun. See? Quick blast with the heat gun, and all the PLA hairs have fallen off or shrunk into the model. Alright, let's continue working on the next side. Glorious. Look at that. Slides so smoothly. Check that out. Oh, this should work. This other side is heavily covered in supports, even on the bottom. It's gonna take much longer, but we're gonna get it done. Woo! Bro, it's gonna be a big mess.
Alright, let's see if it fits. Ooh. That's impeccable. Look at that. Fits perfectly. Now, let's see if they fit together. Let's see. Fits. We made it to the 10-minute marker. We're gonna end the episode right here. Next episode, you guys are gonna see the very first sculptural mold getting packed. The long-awaited moment. I know I've been eager to get to that part to show you guys. Stay tuned for the next episode dropping next week. If you have any questions, feel free to drop them below in the comments. Thank you very much for watching MycoSpace Trip Episode 3.